9.6 is all about remembering that finding the solution to a quadratic equation with an x squared, or solving for x, is the same thing as finding the x-intercepts on a parabola, which is the same thing as finding the zeros, which is when y equals 0. Saying that one more time, solving for x, what does x equal that will make this true in a quadratic equation, is the same thing as finding the x-intercepts, or the zeros, on a parabola. Last section, we talked about how to find these points graphically by looking at the graph and estimating where that parabola crossed the x-axis. More recently, we have learned that there is a way to solve for an x, solve for these solutions, intercepts, or zeros, algebraically by using factoring. I can solve a quadratic equation by factoring, and the way to do that requires the zero product property, which it reminds us that if two things multiply to be 0, either the first part equals 0 or the second part equals 0. And last time we talked about how if we set x minus 3 equal to 0, the first part, or x plus 7 equal to 0, the second part, we can solve for x very easily and determine the values for x that will make this equation true. Those values are also the ones or the places where that parabola, when graphed, will cross the x-axis. We have 3 steps that we can follow when we're trying to solve a quadratic equation by factoring. Step number 1 is to write the quadratic equation in standard form, from highest exponent down to lowest exponent on the x. Step number 2 is to factor the quadratic equation using techniques from chapter 8. Step 3 is to use the zero product property from above and set each factor equal to 0 and solve. We're going to start by solving this quadratic equation by factoring. Step number 1, to make sure that it's in standard form. X squared, x, and no power. Yes, it is. Step number 2 is to factor the equation. Do you remember from chapter 8 we had a factor tree? Step 1 was to put it in standard form, which we just did. And then step 2 is to ask ourselves, can we factor out a GCF? And if the first term is negative, we need to factor out a negative GCF. Now, we do not have a GCF in this equation because nothing goes into x squared, 7, and 10 except for itself. Step number 3 is to ask how many terms there are. There are 3 terms. So we're going to ask ourselves if a equals 1 or is a greater than 1. In this case, our a is equal to 1, a equals 1, b equals 7, and c equals 10. That tells us that we can use our shortcut, which is the x method, and putting our 2 answers straight into parentheses. I'm going to ask myself what 2 numbers multiply to be a times c, which is 10, 1 times 10, which is 10, and what 2 numbers add to be 7. Those 2 numbers would be 2 and 5, and I'm going to factor that parenthesis, keeping it equal to 0. So these 3 terms are now going to be written as x plus 2, x plus 5, taking these 2 numbers and putting them in these 2 spots right here. Remembering our zero product rule, either x plus 2 equals 0 or x plus 5 equals 0 if they multiply to give me 0. Then x would either equal negative 2 or x would equal negative 5. And those would be my 2 solutions. On a graph, this would look like 2 zeros, one at negative 2 and one at negative 5. Because our a value is positive 1, our graph will open upwards. We don't know exactly our vertex, we could find it, but we know that our y-intercept is 10, so it'll hit way up at 10 and cross over. But it'll look something like that. Notice on this particular one we have two solutions or two values for x that will make this true. If you remember back from your portfolio, parabolas can either have two zeros, one zero, or no zeros, and we'll see more examples of that going forward. Looking at this next example, step number 1 is to write the quadratic equation in standard form. So we want to get all of the terms on the same side of the equation. We're going to start by adding 2x squared to both sides. That's going to give us 0 equals 2x squared. I'm going to write my x term next, minus 12x, and then my constant to make sure it's in standard form, from highest power to lowest. Step number 2 is to factor the quadratic equation, if possible, using the techniques from Chapter 8. Looking at our factoring chart, we already put the polynomial in standard form. Step 2 is to see, can we factor out a GCF? Let's take a look. 2, negative 12, and 18. Is there a GCF that we should factor out first? Yes, there is. They're all divisible by 2. So we're going to factor out our GCF of 2 first, dividing each term by 2. We're left with x squared minus 6x plus 9. This is all still equal to 0. Our next step then is to determine which type of factoring we should use. To determine this, we look at how many terms are left in the parenthesis. There are 3 terms left in the parenthesis. So now we're going to see what is the value of a. Because a is 1, we can use the shortcut. The shortcut tells us we can put our terms into 2 parentheses and use the x method. I need 2 numbers. Well, first let's say a is equal to 1, b equals negative 6, and c equals 9. I need 2 numbers that multiply to be AC, which would be 9, and 2 numbers that add to be b, which is negative 6. What are those 2 numbers? Negative 3 and negative 3. Those 2 numbers we can drop straight into a parenthesis, x minus 3 times x minus 3, bring down my 2, and bring down my 0. From our zero product property, we know that if 3 things multiply to be 0, 2 times x minus 3 times x minus 3, 1 or all of them must be equal to 0. So either x minus 3 equals 0, or the other x minus 3 equals 0. Adding 3 to both sides, we get x equal to 3 for both. And what that tells us is there is actually only one solution, x equals 3, that will make this equation true. What will this look like on a graph? Well, our graph tells us there is only one solution, or 1, 0. So that means our parabola is actually going to have its vertex right at 3. Because our coefficient of a is positive, our parabola will open upward, which means it will look something like this when graphed. Notice that there is only 1, 0, or solution for this particular quadratic equation, but on the example we did right before this, there were 2. Let's look at this example. Step 1 says to write the quadratic in standard form when we're going to try to solve for x. So our first step will be to get all of the variables onto one side. Let's add 9x squared to both sides. I like to try to have my x squared term be positive, so that's why I chose to add it to the left this time and to the right the previous time. 9x squared plus 30x equals negative 25. Now we'll add the 25 to both sides and get 9x squared plus 30x plus 25 equals 0. Step 1, the quadratic equation is written in standard form. Step 2, factor the quadratic equation using the techniques from Chapter 8. Looking at our factor tree from Chapter 8. We already did step 1 to put it in standard form. Can we factor out a GCF? Looking at 9, 30, and 25. Is there a GCF that we should factor out first? No, there's not. If you go through those factors, there isn't. And we did make sure that the first term was positive. If it was negative, we would have to factor out a negative. How many terms are there? There are 1, 2, 3 terms, so we're going to be in this box again. Does A equal 1? No. A equals 9. That means we're going to have to use this long version, where we split up the middle term into 2 terms and factor by grouping. Let's remind ourselves how to do that type. We're going to take our middle term and split it up into 2 terms, keeping the first term the same and the last term the same. To decide what those 2 middle terms will be, we're going to take a look at our x. Our giant x method tells us we're going to find what 2 numbers multiply to be a times c, or 9 times 25, which is 225, and add to be b, which is 30. The 2 answers would be 15 and 15. Those multiply to be 225 and add to be 30. So I'm going to write those 2 numbers over here as 15x and 15x. Notice that 30x can also be written as 15x plus 15x. After I break up those middle terms, I am ready to factor by grouping. I group the first 2 terms in a parenthesis and the second 2 terms in a parenthesis. Now I look for the GCF. The GCF of the first parenthesis would be 3x. I factor a 3x from both terms in that parenthesis to get 3x plus 5. Then I factor the second parenthesis GCF, which would just be 5. Dividing both terms by 5, I get 3x plus 5. Remember, this parenthesis must be the same as this parenthesis to factor by grouping. Otherwise, we did something wrong. Because they're the same, I can factor the 3x plus 5 out as my GCF again, and I'm left inside with 3x plus 5, all equaling to 0. My final step up from the beginning is to use the zero product property to set each factor equal to 0 and solve. Well, because these 2 terms both multiply to give me 0, I know either the first term equals 0 or the second term equals 0. Just like in our last example, they're the same term. So we note that we will actually only have 1 0 in this case, and that 0 will be negative 5/3. So again, when we look at this on the graph, negative 5/3 is negative 1 2/3, so about here. We note that our original parabola had a positive a value, so it will be opening upward, that parabola. And it will look something like this, with having only 1 0 as our solution. Remember, a quadratic equation can have either 1 0 or 2 zeros, or even no zeros. We won't get that yet, but we will see very soon that if something is not factorable, there is a chance that it has no zeros. It also might be that they're very long or decimal answers, and we do have a method we'll learn later on to find those zeros. Let's take a look at this word problem. The height of a diver above the water during a dive can be modeled by this parabola, where h is the height in feet and t is the time in seconds. Find the time it takes for the diver to reach the water. Now for this diver, he's standing up on a diving board, ready to dive into the water, and his dive can be modeled in the shape of a parabola. The other side of the parabola won't really matter in this case because our x-axis is time, and time starts at 0 moving forward. Now our goal is to find at what time does he reach the pool? The pool is this part down here. Okay, the time that he reaches the water would be at this point right here, which we know can be modeled as a solution, a zero, or an x-intercept. So we're looking for this particular x-intercept, which we can solve graphically by factoring. We know that our first step is to take a look at the height that the diver will be at when he reaches the water. His height when he reaches the water will be at 0, at y equals 0. So I'm going to plug in 0 for my y. Remember, h of t is just a fancy way of writing y. And then I am going to make sure that it is in standard form, like our step 1 says, which it is. It's from highest exponent to lowest on the t. Step 2 then is to factor. And when I take a look at my factor tree, I notice that the first step in factoring is to see if we can factor out a GCF. There is a GCF in this case. The GCF would be 8. Factoring out, actually we're going to factor out a negative 8 because our a term is negative, our first term is negative. Factoring out a GCF of negative 8, I'm going to be left with a positive 2t squared minus 1t minus 6. That will all still be equal to 0. Now I'm going to factor what is in the parenthesis. There are 3 terms, but the a is greater than 1. It is a 2 here. And so I'm going to have to use my long method of factoring. A is 2, b is negative 1, c is negative 6. I need 2 numbers that multiply to ac, or negative 12, and add to bb, which is negative 1. Those 2 numbers are going to be negative 4 and positive 3. I'm going to break my middle term into negative 4t plus 3t, because those add to be negative 1t. I'm going to carry down my negative 6, carry down my negative 2t squared, and I will keep those terms in that parenthesis. My negative 8 carries down, and my 0 carries down. Next, I am going to factor by grouping. This first chunk I will put into a red group with a GCF of positive 2t. That will leave me left with t minus 2. Then I'm going to factor my second group into a green group. My GCF would be 3, leaving me with t minus 2. Remember, that's all in that big blue parenthesis with a negative 8 in the front, set equal to 0. Let's erase this part just for a little bit more room here. Continuing to factor, they all have a factor of t minus 2. That will be factored in the front, leaving me with 2t plus 3. Still have my negative 8 in the front and still set equal to 0. Now that zero product property tells me that either this first term, t minus 2, equals 0, or this second term, 2t plus 3, equals 0. Solving, I get either t is equal to positive 2 or divided by 2, t is equal to negative 3 halves. Well, looking at our picture, the negative 3 halves is going to be way over here, and we are not looking for that 0. We are looking for the positive 2, which is when he actually jumps into the water. My 0 here is 2, 0, which means that time 2 seconds, that is when he reaches the water. So in answer to the question, find the time it takes for the diver to reach the water, it takes him 1, 2 seconds to reach the water after he dives in.